Assalamu alaikum everyone. Hope you guys are well by the grace of Almighty. I'm Shama Chaudhary Imran and welcome back to my channel. As we all know, we are making videos on different financial tools of Excel used in business. In our last video, we talked about our some basic uses of Excel financial tools for business. To follow that chain, today we are going to talk about and make a video on such tools that are simply used in business and the simple use of them, but it has a great impact on our day-to-day business functionings or business activities. Today we are going to learn about them. So let's start the video. Here we have our Excel sheet. Uh, Today we are going to learn about effective annual rate. So we all know what is effective annual rate. Effective annual rate is the actual rate what is charged or paid on any investment or any investment or any financing we take. So let's calculate it. To calculate the EAR, effective annual rate, we are going to use very carefully. We can see that we have our present value, so we're going to use the future value. Present value is here to just to multiply the percentage or the interest rate to get an actual rate. So here the rate is for rates, we have to click this one and divide it by the par, the period, then 1 into this one, and if a payment 0, our present value is 1, and type is not necessarily going to say 0 for as usual. Okay, so as we have mentioned the PV as 1, so we have to minus 1 to calculate the actual rate. So we're going to minus 1 for this. As we have multiplied 1, so we're going to minus 1, so the rest we'll get is the percentage. So this is our formula. Enter. So it is $0.13. It's showing dollar sign, so we're going to change it to number. Okay. And if as it's an interest rate, we are going to take it in percentage, so it's 13%. Okay, so it is 13%, showing 13%. 13% is our effective annual rate. So let's move to next one. The bond value. Bond value is very important in investing in bond. So what we get in future, we have to calculate it as in our present value to see whether it's a premium bond or or an discount bond. So according to the maturity or yield to maturity, we're going to calculate our bond value. So now we are going to calculate our present value of bond. So here the rate is what we get at the maturity. So the rate is 12%. Okay, so this is the rate. Then our period is 20 years. Then our payment is the interest rate according which we'll get the payment. As we can see, it's a premium bond. The payment will be per value into coupon interest rate. Okay, and our future value is 1000, what do you get at the maturity. So we're going to close it and enter. So see, it is the present value of our bond. Using the present value and calculating with our interest rate, we can get our present value of the bond. So let's move to the next one. It was easy how to calculate the bond, to calculate the bond future present value of the bond to compare with the market with this formula. Now it's capital budgeting. Capital budgeting is very important in business aspect to take different long-term decisions, where to invest, where to finance. So it is very important. So we're going to learn how to calculate. So an important element of capital budgeting is NPV, net present value, and IRR, internal rate of return. So here's a predefined formula for this. So we're going to use NPV V it is. So we are going to use rate is discount rate as 8%. Sorry, 8% and comma. So value is our net cash flow. Not all that the cash flow that the project generates. So here this from this to this. We can also use shift control and right arrow to click this one, our project net cash flow, and here it is. So as we know, to calculate net present value, you have to subtract the amount of initial investment so that we can get the net what we have generated. So as it is in negative form, uh, we are going to include as plus and cumulative cash flow, our initial investment. So we're going to decrease the initial investment. Okay, so that's it for calculating the NPV. So this is what we get if we were to highlight it. So with this we can use to highlight it. Or now if we want to calculate the IRR, now if you want to calculate the IRR, okay, now we'll calculate IRR. To calculate IRR, we're going to use the formula IRR. As we all know, IRR takes into account only the cash flows, total cash flows. Present value gets at 0. So we are going to use our net cash flow, all the net cash flows for as our values. So we're going to shift control. So these are all the values we're going to. So that's it. The rest will be on Excel and enter. Here it is 10%. If we take two decimals, so we can get 10.3% is the real rate, or if we don't take it, it will give us a round up score. So we're taking two decimals only. You can highlight this one with the box. Now if we want to calculate the payback period, so there's a formula for calculating the payback period. So we can calculate it manually. If we see the results after the third year, our cash flow started getting positive. So this means we are getting from this side, we're getting a positive. Let's say we can get a positive from after third year. We're getting a positive cash flow. So this is our payback period, and after finishing the fourth year, totally fourth year, we are getting our initial investment. So our cash flow will be 3. So we're getting our last negative is 3, so it will be 3 plus. To get the exact result, we will use absolute formula. Absolute, this will result in absolute. So we're going to use this one to divide by how much time it will take to earn 4,50,000 of 4,90,000. So here it is. So if we click enter, so it is. So we have get the result. It's 3.90 there. So if we want to reduce the decimals, so we're going to reduce it to 2. So it's 3.91 years. So it is 3.91 years that we need to get our total investment back. So that's it. We are going to calculate the same things for our project 2. So I'm going to do it a little bit faster. And PV. So it is NPV. So first is our discount rate. Our discount rate is 8%. Our values are this, that the net cash flow that generated by the project. Okay, this one. We can close the bracket, and we can subtract our initial investment. So we get the net present value. We're subtracting our net present value. So this is what we get, 23,834. If you want to round up the score, we will decrease it with this one. Okay, so now if we want to calculate the IRR, we'll use the formula IRR simply. Okay, the values, we know that the values are the total net cash flows that are generated by the project, and the rest will be upon our Excel. So it is 11%, and if we want to take it as percentage of 2 decimal, so it is the percentage, and if we want to highlight it with a blue, say this one with blue, mm, and our payback period has the negative values ends at 3, so we're going to use 3 plus. To get an absolute value, we are going to use F, our formula. The numbers are like how much the 57,600 are going to get from 76,000 with the formula, and enter. So it is, so we're going to decrease our decimals to 2, so it's 3.76 years will be needed to get that. So if we want to take decision whether which project to get, so we'll see that our net as our two most important things are elements are IRR and payback period. So our payback period is, we can see that our internal rate of return is more in project B, and the payback period is also less in project B if we want to take any of this. So we are going to take, I shall say we're going to take the project B. So as it is more benefited, as it is seen as more benefited for to us, more benefit to us. Now here comes the most important part of calculating internal rate of return. Internal rate of return, this has some limitations. IR has some limitation that it doesn't calculate the say, let's say timing of different timings, so that the transaction can happen in different time segments, or different the project's cash flow can have different time segments of year and different time zones. So, and it doesn't calculate the capital reinvestment, in reinvestment rates and capital rates in, and so it's have some limitation on that. So to get the more idea, let's see some definitions. As you know, what is IRR? IRR is the discount rate or interest rate used to calculate the present value of future cash flow. It's the annual rate of return an investment generates, considering all cash flows and outflows when their present values are exactly balanced. So it's a discount rate or interest rate to calculate the present value, and it's an annual rate and investment generate, IRR. But what is we have seen, or we have calculating XIRR and MIRR. So how these two things eliminates the limitation of IRR. So let's see, XIRR it means extended internal rate of return is a financial metric used to calculate the annualized returns on investment where multiple cash flow occurs. Multiple cash flow occurs at different times for different time zones, for not a simply for a year or year two starting at the same time of the year or the next year, but it can happen many at any time of the year or at any time zone. So XIRR considers the timing and amount of cash flow to provide more accurate representation of overall investment performance. So then what is MIR? MIR is modified internal rate of return. It's also a financial measure used in capital budgeting that provides a more realistic assessment of an investment profitability than the traditional internal rate of return. MIR considers the reinvestment rate. Yes, it's considered a reinvestment rate of positive cash flow and financing rate of negative cash flow. So we have to calculate the if the cash flows are negative, we have to calculate the financing rate which we have you paid to finance, and if it has a positive cash flow, we always have to calculate the opportunities as reinvestment rates. So if we compare both, XIRR is suitable for investment with irregular cash flow and variable time periods, and MIRR is used when the reinvestment rate are different from cost of capital. So let's get into it. So we can understand that MIR and XIRR eliminates the limitations of IRR. So first we're going to calculate the IRR. So as we have mentioned earlier, IRR IRR takes into account, so for project A the IRR will be simply that, and we conclude and enter. So it is 19.86%, and for project B it will be From this, we actually cannot get a true answer. As we have on one, we have invested 42,000, another 45, and the cash flows are looks to occur at different time zones. Which on which one gives us an annuity cash flow, but the another one has uh, different cash flows, different cash flows. So to get that, we are going to calculate our XIRR, which will take into account our different cash flow and the timings. XIR will cost timings. So for this, we are going to use XIRR. XIR, and we know our values are projected this. Then our dates are this. Now we will get a more accurate answer. This 22.5, which differs from our actual IRR. Same, we're going to calculate it for project B. It will be XIRR. So our project B's values are here. Then our dates are here. And conclude, enter. It's generate 26.43, which differs a lot from our IRR. So what if we take our cost of capital as 12%, 12% for retirement? Then cost of capital is important. It's also important to calculate the time value of money and use the concept time value of money. And so am I taking into account the time value of money and the reinvestment and capital rate? So we are going to take cost of capital for that. So then MIR. So values are for project A this. Our financing rate is this cost of capital, and if we want to reinvest, we're going to reinvest again in this. So enter. So our MIRR is 16.9%, which is less than the actual IRR. And if we calculate our project B, the MIR will be our values and our financing rate and our reinvestment. As we don't have any investment rate, we'll take cost of capital as our investment rate. The less we must earn. Okay? It's 16.04%. So now we have more accurate and more detailed data to take our investment decision. So these are more accurate than IRR, as it eliminates the limitation of IRR. So we can use these formulas to get our result and take our effective and efficient decision. So now let's move to next. Now let's move to next one. To this most important part of this learning, I think, is loan amortization schedule. So loan amortization schedule is very important in paying our loans. To know what actually we are paying and how many we're paying. So it's very important. So we're going to learn how to do it. So let's go. First of all, we have to count our payment, our total payment for each annuity, of payment loan. For this, we're going to use our formula payment, which automatically defines the payment. We're going to the rate 12%, as we are paying on year 12 payment per year, so it will be divided by 12. Okay, the NPAR will be 15 years into 12 payments. Okay, we're going to have 12 payments. Then our present value is 5 lakhs, and there's no future value for this one, so 0, and we're going to take it at the end of the year. So okay, so that's it. So enter. So this is our payment rate. So now we are going to make our amortization schedule. So months. So months are important, very important. It means how many payments for this we can use, not use month. Okay, we can use months as we are making the payment per month. So how many months, as it will be important in calculating the payment and interest payment and principal payment. So it's very important to know how many months we should list. So if for this a simple formula we can use is, we can say that we have 15 years, and if we pay 12 payments per year, so in 15 years we need 15 into 12, 180 payments. So we are going to make 180 months. So for this it's 1, 2, 3, 4. So if this is the land process, we're just going to drag this one and take it to 180. Okay, it's 180. So see, there's 180 payments are here. Easily I've just dragged our payment, and now there's no need to count payment for everyone. As we know, the annuity payment is always the same, so we're going to just, as we have calculated earlier, we were going to copy this one, and copy this one and paste here in number one from when our payment gets started. So we're going to paste this one, and as we have to drag it down, we have to make all of this element constraint so fixed. So for this we are going to use F9 F4, then this one F9 F4, then this one F9 F4. Okay, now enter. Now if we drag this along the side, so if we drag this along the side, we get the results. Now for this, first of all we have to take our balance of 5 lakhs. We're going to make it as currency. Okay, now we are going to calculate our interest payment of total payment. For this we are going to use the interest payment. It's also a formula. For this we are going to use the rate is 12% divided by 12 divided by 12. Now the par is the number of months. Okay, now the NPAR is the number of years. The par is number of months. The year. NPAR is into payment per year. The present value is the principal amount, and the rest is 0. Hope we're getting the answer. Okay, we're getting the answer. Now we're going to calculate the principal amount. The principal amount is, for this we're going to use the formula PPMT, the principal formula. The rate is, again the rate is 12%, and then our par is first month, then our NPAR is 14 into payment per year. Present value is the principal amount we follow, then the rest is 0. We conclude here, and we get our principal payment. So this is our principal payment. And now if we want to drag along, we have to make something fixed. For this we're going to make this constant fix as our rates, and this thing's not going to change. Our power will not remain constant, it will change as we change, it will change as we drag, so we're not going to fix that one. I'm going to fix the rest ones, and our balance value also remain fixed, so entering, we get it, and we are going to fix our principal payment also. For this we are going to, instead of path, except path, we're going to fix everything, the path. So now if we drag along the side, we get our interest payments, and then as the time increases, our principal payment increases and interest payment decreases. So this is our interest payment, principal payments. So now we are going to make our balance. What is the balance after every payment we do? For this we have to use the formula. We're going to minus our this one. So for this, as it is in minus, we are going to use minus. I'm going to use the plus sign to use this one. Okay, enter, we get 49. So if I drag alongside, so at the end of the period, the payment schedule, our balance payment get down to 0. So here we got our amortization schedule. So using this, we can calculate how much time we need and how much payment we need to do for interest, for principal, and how will be what will be our balance payment. Using Excel, this thing get more easier, and this thing gets more easier. Now we're going to turn it into dollars. Now it's easy for us to understand. So this makes our day-to-day business transaction and business activities more easier and more impactful. So that's all for today. Hope it was helpful. Thanks for watching. See you soon, inshallah. Till then, stay safe, stay happy. Assalamu alaikum.